Okay, 10.3 part 2. So we did the first part yesterday. Well, Monday. This is now Wednesday. And we can go on and try these again. So now we're going to do the sum. So the sum S sub n of the first n terms of a geometric sequence is given by, and then we're given this formula, in which a sub 1 is the first term and r is the common ratio that's not equal to 1. Because obviously that would make it a 0 in the denominator, and we cannot have that. Take a second, write it down, pause the video if needed. So this example says find the sum of the first 9 terms of the geometric sequence, and then we have 2, negative 6, 18, negative 54. So a sub 1 we know is 2, but then we have to find that ratio. And so an easy way for us to do that is going to be doing your second term divided by your first term. You see it's negative 3. And if we double check that, you see to get from negative 6 to 18, you multiply by negative 3, and it is 18, and negative 18, or positive 18 times negative 3 gives you negative 54. So we're good there. So we're going to use that formula from the last slide. S sub n equals a sub 1, 1 minus r to the n, all over 1 minus r. So we're looking for S sub 9. And then we have my first term 2, parentheses 1 minus negative 3, parentheses around that to the 9, all over 1 minus negative 3. Be careful, the reason we put that parentheses around it is because that the 9 on the negative 3 is going to keep it as a negative. Okay, and then we go on here. We end up with 2 times 1 plus 19,683 all over 4, which gives us 9,842. So the sum of the first 9 terms is 9,842. Okay, we're going to go on to try it yourself. So the sum of first 18 terms, and they are going to be 2, negative 8, 32, negative 128, dot, dot, dot. A sub 1 is 2, r equals negative 8 over 2, which is negative 4. So sum of 18 equals my first term, 2, 1 minus my rate of negative 4 raised to the n, 18, divided by 1 minus negative 4. We know this bottom part is going to be equivalent to 5. Okay, so give me a second while I try to figure out the 4 to the 18th power, or negative 4 to the 18th power. This would be really helpful if I had you guys with calculators with me. So that way I wasn't going to have to go in here and do it myself. So parentheses negative 4 raised to the 18. A really big number. Okay, so we have 2 parentheses of 1, and then this becomes minus, and then 6, 8, 7, 1, 9, 4, 7, 6, 7, 3, 6, all over 5. Okay, so let's do 1 minus that. So Okay guys, I got my calculator to work, so I filled in this portion. Double check me if I'm wrong, but 1 minus all of that gives me negative 68719476535, and then multiplying it by 2. And when I put that in, I got negative 13743895370 divided by 5. And I'm going to arrive with negative 274877900614. Double check your math on that again. I'm using an iPhone, but that looks about right. Okay, let's go on. Okay, the value of annuity interest compounded n times a year. So if P is the deposit made at the end of each compounding period for an annuity at R% annual interest compounded n times per year, with the value of A of the annuity after T years is given by this formula. Please take a moment, make sure you have it on your page. My page froze. Okay, there we go. Hopefully you guys got that, because my page froze. So take a minute, write this down. So at the age of 30, to save for retirement, you decide to deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. How much will you have in your IRA when you retire at 65? So we have our rate as 0.095, because remember that's in percent, so we're going to change it to decimal. My N, it says compounded monthly, so N equals 12. And then my time is, I'm 65 when I retire, but I started it at 30, so 35 years. Okay. So I'm going to use that formula, A equals P1 plus R over N, NT minus 1, all over R over N. So we want to find the value of our annuity. We have our principal of 100. 1 plus 0.095 all over 12 times 12 times 35 years minus 1 all over my rate of 0.095 divided by 12. Again, put this into your calculator. And if you were able to find one with this percentage rate, you'd end up with $333,946. Which is, I don't know for retirement if that's a lot, but at least it's something. Your try it yourself says if you save for retirement and you deposit $1,000 into an IRA at the end of each year for the next 30 years, and you have a rate of 10%, and your time is 30, and it only compounds annually, so n equals 1. We'll find this value, so $1,000, 1 plus 0.1 over 1 times 1 times 30 minus 1. Let's make sure I put my parentheses and brackets in the right places. All over 0.1 over 1. Okay, again, gotta get a calculator to work with this. So give me a second. Okay, so this is telling me that 1,000, the part in the middle is what I just did in my calculator, and it tells me that that should be 17.449 minus 1 all over 0.1. So we know that that's going to be 1,000 times 16.449 divided by 0.1. So that gives me $164,490. Okay. And here we have the sum of an infinite geometric series. So infinite means it goes on forever. If the rate is between -1 and 1, or you could write it as the absolute value is going to be less than 1, then we have a sub 1 plus a sub 1 times r plus a sub 1 times r squared, blah, 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 which is given in which a sub 1 is the first term and r is the common ratio, given by this formula. So the sum of an infinite geometric series is the first term divided by 1 minus the rate. And that's what we're going to use. Okay, so example 5 says find the sum of an infinite geometric series with a sub 1 equaling 3 and your rate being 2/3. So we use that sum equals 3 divided by 1 minus 2/3. Gives you 3 over 1/3, which we know is a fraction in the denominator, flips up, multiplies by the reciprocal, and you get 9. So the sum of an infinite geometric series with this information gives you 9. And then we have a try it yourself, where you're given, I think I'm missing a few commas in there, so a sub 1 being 3 over 8, and then your rate being, and you're given 3 over 8, comma, negative 3 over 16, comma, 3 over 32. So if you look here, without actually going through the motions of figuring this one out, you can look and see the only thing that's happening is that they're changing from positive to negative. You know it's going to be negative. And because it's alternating, the top number is staying the same, so that's not changing. So what's multiplying on the bottom? 1 or 8 times what gives you 16? Well, 2. So we could look at it that way, or you can go through the motions of doing that. Negative 3 over 16 divided by 3 over 8, which is equal to negative 3 over 16 times 8 over 3. 1, 2, negative 1/2. Okay, so we have the sum equals 3 over 8 over 1 minus, and then my rate of negative 1/2. Okay. So that gives me 3 over 8 over, and then it's 1 plus 1/2, which is 3 over 2. So 3 over 8 times 2 over 3. So our sum here is going to be 1/4. Okay, thanks guys. This is it for today. Try those problems.